So yes, today I'll be talking about ClearTK, which is a software framework for developing natural language processing applications. One of the main goals of this event is to promote the development of community-driven, open source tools for biocuration and BioNLP in general. So today I'll be promoting ClearTK as a promising platform to aid in the development of these tools. So I thought a good way to go about doing this would basically be to walk through the process of creating a simple NLP component within the ClearTK framework. And I chose entity recognition because it's a fairly straightforward task to conceptualize. And more importantly, it's used in a wide variety of NLP applications, especially in clinical and biomedical domains. So before I get to that, I'll just start with a brief overview of what exactly ClearTK is. ClearTK provides a framework for developing statistical natural language processing tools. This can really be thought of in two major parts. The first part of this is an interface for lots of popular machine learning libraries like libsvm and mallet. It's a common interface in that the API for using each classifier is the same. So if, for example, you're using mallet's implementation of conditional random fields in your tool, and you decide that it's running too slow and you want to try out a different implementation of CRFs, then you can simply plug in a different machine learning library like CRF Suite, and this essentially requires no changes to the rest of your application. The second part of this framework is to provide a feature extraction library that's usable with any of these classifiers that are wrapped into ClearTK. So you basically define these features the same way for every machine learning library that is wrapped into ClearTK. So all of the conversion between the different formats for each classifier is handled under the covers. So it's, in essence, an extremely just plug-and-play sort of framework. So together, these two components make up the core of ClearTK. They allow you to define and tackle basically any text analysis problem that can be framed as a classification task. So in addition to this core framework for statistical natural language processing, we also include a number of components to aid in the development of NLP tools. We have corpus readers for popular corpuses like the Pin Tree Bank, Time Bank, ACE 2005, Prop Bank. And basically, these make it really straightforward to read data into your applications. So also, we include some homegrown components for tasks like tokenizing, part of speech tagging, dependency parsing, semantic role labeling, and extracting events, times, and temporal relations. And finally, we also wrap in some external components for NLP software packages like OpenNLP and Stanford Core NLP, as well as like some stemmers and parsers like the Berkeley parser. So one thing that's pretty important about ClearTK is that it's built on the UIMA framework. So I'll just give a quick overview of what UIMA is for those unfamiliar with it. Basically, UIMA stands for the Universal Information Management Architecture. Oh, I'm sorry, the Unstructured Information Management Architecture. And basically, all of the components, what UIMA provides is a interface for components that analyze unstructured information. In our case, unstructured text. So as you can see in this diagram, the components are all organized around a type system that defines the structure of annotations that can be added to each document. The type system is instantiated in a data structure called the CAS, the Common Analysis Structure. And in a typical UIMA pipeline, the CAS is initialized in the collection reader. This basically reads in all of the documents that need to be analyzed, adding any prior annotations, et cetera. And then the CAS is passed along through a series of analysis engines that add or modify the existing annotations. So you can kind of see how the CAS is the key to the interoperability between the different NLP components using UIMA. So on the subject of type systems, ClearTK has its own type system, defining types like sentence, token, for tasks like semantic role labeling, and named entity recognition and parsing. We also have types like arguments and predicates, named entity mentions, and that sort of thing. But it's important to note, however, that this type system is completely divorced from the core statistical natural language processing framework. So basically, this allows us to work with all of these different UIMA applications. So to go into this walkthrough, I'll first give a brief overview of exactly what named entity recognition is as a task. So in general, named entity recognition, we're trying to classify elements of text into predefined categories, like person, location, or organization. And more specifically, to facilitate locating entity boundaries, we are going to do what's called IOB labeling, in which we classify each token as marking the beginning, the inside, or the outside of an entity. So to be slightly more relevant for this event, I thought it would be interesting to just develop a biomedical named entity recognition component. This is taken from 2004 named entity recognition task at the joint workshop on natural language processing and biomedicine and its applications. Basically, I found this just Googling for biomedical named entity recognition. The data comes from the Genia corpus, which is basically made up of journal abstracts from articles containing terms, human, blood cells, and transcription factors. So as you can see, we have an example of the IOB format and the different entities. So the first thing before we can do any sort of supervised statistical NLP is that we need labeled examples of the sort of text we're trying to classify. So once we find that data, we need to use a collection reader to actually read the documents into the CAS in UIMA. So I mentioned before that ClearTK provides some collection readers for common corpuses. But in our case, since we don't have a collection reader for this BioNLP 04 task, we're going to want to use a generic collection reader just to read in the files, the pure text, the raw text from the documents. And then we'll need to use an annotator to extract the actual labels. So just to show you the format for this particular corpus, it's broken line by line for each token. And the label is separated by a tab from the token. And blank lines separate sentences. So I needed to write a very simple parser to read this into the CAS. So once we've read our data into our application and we have our labeled text, we need to create training data. And so to do this, we'll be extracting features that will help us to identify unlabeled text. So here I just included some pseudocode. Essentially, we're going to loop through all the sentences, which are annotations that we've added to the CAS, using our data. And then for each token, we're going to extract features, because we're trying to classify these tokens into these particular pre-established classes. And then we're going to create an instance, which will be used for training the machine learning classifier later. So ClearTK, as I said before, essentially allows you to just describe your feature in a very simple way, and all of the conversion to the different formats between each machine learning classifier is handled under the covers. So just to go into a little more depth about ClearTK's feature extraction system, I am providing here two very basic feature extractors that we have. These provide a lot of flexibility for extracting a wide variety of features. The first of these, the token feature extractor, extract features from a single annotation. So if that's a token, we can extract a feature like something as simple as the actual text of the token, or we can extract lexical features like character level engrams, the capitalization patterns, or the presence of particular digits or Roman numerals. And all of those lexical extractors are also included with ClearTK. So the context feature extractors allow you to extract features from multiple annotations that are located relative to a particular focus annotation, for example, the token that you're trying to classify. So you can use this in a lot of different ways. For example, you can extract tokens. You can extract features from all tokens and two tokens to the left or right of the current token you're looking at. You can use it to extract nouns and adjectives from all of the surrounding sentences in a window of plus or minus 3, et cetera. So basically, our feature extraction system allows for extremely flexible definition of features. And it's also very extendable. You can add your own features very easily. So I'll continue. So once we've defined which features we're going to use and we've extracted them to these instances, we need to train a model. And here I've included some code that's actually from ClearTK. Essentially, what we're doing here is adding to the pipeline of analysis engines the particular feature extraction class that we used, as well as at the bottom we have the mallet CRF string outcome data writer, which is the particular machine learning instance that we're using. And it's basically as simple as that to train a model. Obviously, you can include additional parameters to specify more specifics about your machine learning classifier. So I mentioned before that we have a lot of different libraries. In this case, we use the mallet CRF classifier. So conditional random fields are very commonly used for named entity recognition tasks, really any sort of sequence labeling task. And I just essentially chose mallet. So once we've trained our model using our machine learning classifier, the next thing we do is we classify unlabeled data with it. And to do this, we extract features using the same feature extraction method. But for this particular corpus, since we're dealing with text that is specially formatted, we'll have to include a sentence splitter and tokenizer because those are features that were taken from the particular corpus we were looking at. So here I just have some pseudocode. Essentially, for each token, again, we're going to extract features. But in ClearTK, we then, sort of in a similar fashion to, returning to creating training data, rather than just writing the instances, we're now classifying the instances and then adding the IOB labeled entities to the CAS. So ClearTK provides a very easy framework for evaluating your models after you've finished. Basically, you can go through the document, extract the gold entities and the system entities, and just compare them. And so these are the two modules that we've included, training and testing and cross-validation. I've also included some code from ClearTK. So basically, on my way over here, I implemented this system and got some initial results just because I thought it would be fun to see exactly what we could do in a very short amount of time, basically on an airplane flight. And as it happened, using very simple features, for example, 3 tokens to the left and right of the currently being classified token, using character level n-grams, part of speech tags, we were able to achieve, using the CRF, very competitive performance to the systems that competed in this actual task. I believe this, with an F measure of 0.705, this would have been second place. Of course, this task was in 2004, so that's not terribly impressive, but considering that we use extremely simple features, it is interesting. So after we evaluate our model, it's really easy to go back and plug in alternative classifiers, add or modify features, and it's extremely straightforward to, for example, enlarge or shrink the window of tokens we're extracting features for, or add different, for example, if we wanted to add a sort of dictionary type component as an analysis engine, this is something that's fairly straightforward. So I guess finally, I would just like to point everyone to our website where you can find tutorials for developing several NLP tools in ClearTK, including named entity tagging and part of speech tagging. And we also have examples of some other simple ClearTK NLP components packaged in with our source code. And I'd really just like to open it up for questions to try and clarify things a little bit more, if possible. Thank you.
Kevin.
Thank you for a very clear explanation. This is really cool. The one question that I'm wondering is, I can totally see why you would want to use this if this is your introduction to machine learning. If you already have a good workflow set up for something like Weka, would there be a good reason to make the switch to ClearTK? Right, that's a great question. So ClearTK, I think the real selling point is the UIMA, is that it's within the UIMA framework. So we have Weka wrappers, for instance, so it would be fairly easy to convert over to ClearTK in the first place. But more importantly, using ClearTK with this statistical machine learning framework allows you to use it with all these different UIMA components, and it makes it really easy to basically plug in different people's work and try out different things. Was that clear enough? I'm sorry.
Any other questions? I have a couple too.
So you mentioned that the feature extraction library is easily extensible. Could you talk a little bit about how one goes about extending it? Sure. So all of the features basically extend from a very simple class called feature. And so here, let me just go back. No, not necessarily. If you want to add, like, for example, we could use our NER, our named entity recognition component that we just described here as a feature, but you can use existing simple feature extractors to grab something like that. However, if you want to look at something like a complex description of the type of the context that you're looking at for extracting features, like something strange like 3 tokens to the left of the current, or all of the nouns and verbs in the sentence, 3 sentences to the left or something like that, then you can describe that using the feature extractors that we have. But it's very easy to just implement something using the interface that's already existing.
So I have a question. Given that ClearTK is, I actually was able to use ClearTK to do the preliminary document classification that I presented in my talk, and I found it very straightforward to understand and use. And I'm not an NLP person, but given that the focus of this workshop is very much to do with trying to transition out of one paradigm and provide access to the kind of rarefied elements of that paradigm to another community, such as the BioNLP community. It seems that obviously you describe the coding interface, the programming environment of ClearTK as the place in which that integration would happen. So if you have an NLP developer who wants to, a biocurator who knows how to program in Java and has kind of read a couple of books about this and can kind of transition into it, do you think that the coding interface is enough, or does there need to be additional hooks? So, for example, interfaces to the tools that actually link up to PubMed, for example, or tools that integrate with other databases. And if so, is that a kind of task that we can take on here? Because, I mean, whenever we build our own tools, we have to deal with that anyway. But if we can figure out how to address that, maybe that would actually make life even easier for people coming into the field.
Absolutely. So, as I mentioned before, collection readers, we've included some for major corpuses. Oh. And if you're looking at, if we have the UIMA pipeline, and if you create a collection reader in UIMA for something like PubMed, then it would be extremely much easier for people to get into it. Because otherwise you have to develop your own collection reader, which isn't extremely complicated for something as simple as a format like this, but if you're looking to add an XML file that's not necessarily straightforward, then it would be helpful for people with less experience to get involved.
And so as a follow-up, just so one quick question. Are you on Maven? Is ClearTK actually distributed on Maven?
Yes, Maven is distributed on, ClearTK is distributed on Maven.
Right.
So as one of the really naive bio people, so it seemed to me that in this framework context that it's the strength of ClearTK is the ability to sort of plug and play different pieces in, and it reminds me somewhat of some of the genome annotation pipelines I've seen, like the one at the Indiana bioinformatics facility, where they actually even have a web interface where people can just turn on and off which modules they want to use in different places in the pipeline. Is that the kind of thing that one could do with ClearTK? Or is it even something where you could at least distribute, pre-assembled kits that are like, this is the ClearTK version of Texpresso. This is the ClearTK version of.
Well, yeah, absolutely. Like as I said before, the core of ClearTK is this statistical machine learning framework that you have your machine learning interfaces, and then you have your feature extraction library. And so beyond that, creating components, it's within UIMA, creating a pipeline like what you're talking about is definitely something ClearTK can do, and what it should be used for as well.
Any other questions? Great. So this then concludes the natural language processing part of the day, presented the early afternoon. We're back on track again, thanks to people being prompt and having great presentations. So we will now break for half an hour, by the way, I hope everybody is feeling okay. I realize it's been a long day so far. You've only got two more very exciting talks to go. And then we're going to have a kind of open discussion to try and parse out the next steps and stuff that I'd really like to hear from you in terms of what is the most exciting thing that you've heard today? Where do you think we should go? What kind of stuff do you think we really want to try and develop in order to address the initial questions that I asked right at the beginning of the day. So let's just take a half-hour break, get some coffee, relax, rejuvenate your minds a little bit, and then we'll start again in a little bit. Okay? So thank you.